My name is Mike Holler. I'm the Vice President of Operations for PeakLogix, and I'll be walking us through today's material. The discussion topics we will be focusing on, we'll start with an introduction of PeakLogix, who we are, where we came from. We will then dive into what brought us here today and prompted us to offer this specific webinar topic. We'll talk through the robotic solution, certainly focus on capabilities and benefits of such a solution, and then we're going to look at a couple varieties of robotic cells and what they might look like in a real-life application. And then, as Kimberly had mentioned, we'll finish with some question and answer at the end. So first, an introduction of PeakLogix. We've been in business for more than 25 years and have an experienced team that manages our clients alongside our partners. We have a great team here at PeakLogix, about 32 employees overall, and we have a tenured team with a lot of experience in traditional manufacturing, material handling solutions, as well as automated solutions. Our team starts each customer engagement with data collection, and we employ proprietary tools to collect and scrub that client data set. And from there, we can drive towards an ultimate goal together. We're equipment agnostic, which means we represent many vendors from conveyor to automated systems and traditional racking systems, so we can supply the right solution for our clients. And rather than having a fixed set of solutions, we try to stay open-minded about how we solve each challenge and work with our extensive network of vendors to implement the right solution at the right time. We have a team of professional project managers who are instrumental in executing projects successfully, and most importantly, we have a system support group that ensures our clients receive full value on their investment through the life of that system. So we serve a number of industries, primarily distribution and warehouse-based, although we do step into manufacturing at times as well. We apply our learnings from one industry to another to keep our solutions creative, relevant, and current. We have a number of case studies on our website that we'd love for you to visit. Those case studies illustrate the type of work we do for each industry, and I'm going to take a quick look at 4 of these, which are on your screen, from left to right. In the leftmost image, that's a deep pallet flow system storing furniture for a furniture manufacturer. The lanes are as deep as 105 feet long, a little longer than you'd see in a typical application. And we've employed separators, braking, and speed controls in there to manage that product flow. In the second image from the left, there's a product called a module cart, and that's a patented cart that we have designed and offer to one of our customers in the medical distribution field. And that's something that, again, knowing our customers' needs intimately, we were able to come alongside them, work through what features and functions of a cart design would make most sense for them, and then obviously provide that in the end. The third image, which is the second from the right, is a multi-level pick module installed in Ontario, California. And that is used for low unit of measure picking, for medical supplies. And within that system, we're featuring energy efficient, run-on-demand 24-volt conveyor with intelligent carton routing through various pick areas. And then the final picture, a more traditional application where the goal was to maximize storage within a tire supplier warehousing facility. So that's a little bit of background on PeakLogix. I'd mentioned the question earlier, why are we here? The webinar is really in response to our customers' questions about technologies available to meet a very real need they have in their current operation, and that's palletizing of goods. As I'm sure most of us know, manual palletizing can be a quite slow and monotonous process. It's labor intensive for sure. It often presents a safety concern through repetitious motion, twisting and turning, bending, and at times lifting heavy weights repeatedly. It's proven to be a hit on an individual's morale at times as well. And overall, it's simply a costly process to maintain. So there is a better way. In response to the customer's questions asked of us, PeakLogix began years ago investigating technologies that could meet this operational need, And what we found to be a great fit is robotic palletizing, in this case specifically with a pedestal style robot. Since we began designing and installing these systems, they've proven to be highly productive. We offer them in a turnkey fashion, and we have featured a Fuji robot as the centerpiece of the cells that we have provided. I had mentioned earlier that we are equipment agnostic and that we are not necessarily tied to a specific vendor. However, if we find a solution that works, and it works in many environments, we certainly apply that and take advantage of that resource. So in this case, we have found a strategic partner in Fuji Robotics, and because, again, we're going to show their robots in different applications today, I want to at least give a little background on who Fuji is. They are headquartered in Inoda City, Japan, established in 1944, and developed the first palletizing robot in the early 80s. Today, they have over 13,000 Fuji robots palletizing worldwide, and own more than 50% market share in the Japanese market specifically. So obviously a lot of history, a proven track record, and another factor that we like about Fuji is that the robots are designed specifically for the palletizing industry. So they're very focused on simplicity, low maintenance cost, ease of use, and it's not a focus of performing every function within an operation, which some robots in the industry focus more on a broad set of requirements. So again, looking at robotic palletizing, the benefits are clear, and we found 4 themes that were most important to our customer base. Overall productivity, versatility within the operation and within the palletizing function, the efficiency of the operation, and we're going to focus more so on return on investment there, and then reliability of machine and process. So looking at productivity, there's a variety of options available when it comes to robot. What I'm showing here is a model EC201, and with an optimum cell layout and proper working conditions, this unit can execute as many as 1,600 cycles per hour. A cycle being go to a pick point, pick up an item, return to a placement point, which in this case would be a pallet, place it, and then return back to the pick point. So that would count as one cycle. So at 1,600 cycles per hour, that's an equivalent of 26 cycles per minute. And that can be picking up certainly more than one item at a time. If it's small boxes, you can pick up 2, 3, 4 at a time based on your end-of-arm tool and the cell layout. This unit specifically can handle loads up to 353 pounds, and that includes the weight of the end-of-arm tool, the end effector. So if you compare that to 2 team members manually picking and placing, let's say, 25-pound bags of product for an entire shift, obviously a robot that is built to do that doesn't take breaks, doesn't get hurt. Certainly there is an opportunity from a safety and a throughput point of view. I mentioned versatility. The most unique aspect of the robotic cell is often the end effector itself, and again, that's the end-of-arm tool that engages the product. Typical applications can handle, like the images on the screen show, boxes, bottles, cans, bags, books, etc. These all show and employ a clamp-style end effector, but there's other types of end effectors as well, and specifically vacuum that's being used more and more in today's world. That can handle things such as slip sheets, pallets, in terms of putting a pallet into place, as well as the product that's coming down the line. There are several models of robot available. The nice thing about the Fuji line is they all fit and work the exact same way. The variants in models are really simply due to overall size, the rate at which they pick, and the overall payload. So there's a little bit of variability in there in terms of picking the proper unit, but the basic operation, the basic function of each robot is built identical. I mentioned efficiency, and again, we really want to focus on ROI here. We often start the conversation with customers that come to us in a very simple situation, and we say, you know, in a manual palletizing operation, let's say it's staffed with 2 workers across each of 3 shifts. Okay, and if with that staffing model and a fully loaded cost of, let's say, $30,000 annually per person, that's $180,000 in labor cost. Again, this is a sample application to just kind of frame up where a robot could fit in. A simple robotic cell, which we'll see in a few moments in terms of an illustration, with basic capabilities costs around $250,000 typically, and that's an installed number. At that level, the investment pays itself back in under 18 months, in addition to gaining all those other benefits of safety improvement, versatility, etc. Obviously, every application is a little different, and the requirements vary, and that's where PeakLogix comes in to come alongside that client and try to work through what the exact needs are. But as a standalone sample case, this is really where the benefit falls when employing a pedestal-style robot. And we are going to come back to a 3D illustration of a couple different models in a few minutes that will kind of show a little better visually what that might look like. But the fourth theme that we feel is of most benefit to the customer is reliability. The Fuji robots are 4-axis robot design, whereas many in the industry are 5- and 6-axis robots. Those 5- and 6-axis robots are often employed to do different things other than palletizing, such as welding or insertion of screws and things in assembly processes. So again, the Fuji robots focus specifically on palletizing. They're designed to be simple and eliminate unnecessary complexity. And the robots are each equipped with a teaching pendant, which is on the right side of the screen, and a control panel touch screen that the user will interface with. These are used in conjunction to configure the robot setup initially, and then to teach the robot its various stacking patterns as you introduce new products. A quick note, that initial setup of the cell, and you can see in the image where you'd have an in-feed conveyor coming in, a pallet position, a robot position, that initial programming of the cell and really teaching the robot what's there, that's all a function of what PeakLogix or an integrator would do when installing these systems. That's not on the operation itself to do. However, the ease of use of programming in new products and new stacking patterns is made to be so easy that, you know, operators or maintenance staff within a facility could handle that down the road. So a little bit better picture of that HMI, that human-machine interface I had mentioned. Shown on the screen are 2 screenshots of the HMI screens that are used for recipe creation. Again, intuitive touchscreen operation, and there's up to 400 unique recipes that can be stored and easily accessed. And when I say a recipe, that is a unique product stacked in a certain way repeatedly, and that's layers 1 through X, stacking pattern as defined by the customer. And the system comes with a preloaded set of stacking patterns that are pretty common in the industry. However, customized stacking patterns can certainly be made as well. Furthermore, this HMI can provide maintenance reminders, error diagnostics, real-time system monitoring, etc. So this is basically the eyes into the robot. Again, a fairly intuitive system that is made to be user-friendly. From a maintenance point of view, certainly there's preventative maintenance that's required, lubrication of specific points, monitoring belt wear, etc. But the robots are designed to be simple, maintenance-friendly, robust, and live in a variety of environments, which we'll touch on later as well. So changing gears a bit, I thought it would be helpful to take a look at what a few common cell layouts might look like, and maybe as you're looking at these, it might ring a bell as how you would employ these in one of your operations. There are 3 on the screen, and in our world we call them, you know, 1 1 2 2 1 2, and it just code symbols or code numbers for a generic layout. This is basically showing a robot, and in green is the in-feed conveyor bringing product into a cell towards your robot. And then obviously there's pallet conveyor or pallet positions aligned around or near your robot such that the product will be picked and placed onto those pallets. I'm going to transition to the next image because I think that's a little bit easier to kind of walk through. This is a 3D illustration of a very basic cell. This representing kind of that $250,000 level cell that we had talked about earlier in the ROI discussion. This cell offers a single in-feed line presenting units, whether that's bags, cartons, bottles, whatever it is. It has 2 load zone pallets, one positioned on each side of that in-feed line, and has a single robot centered in the cell. The overall cell is enclosed in safety fencing, and although not able to be seen, each of the openings in that fencing are equipped with light curtains to ensure personnel safety and to monitor what's coming in and out of the cell. The robot control panel sits just off to the right, and that houses both the teaching pen as well as that touchscreen interface. And like I'd mentioned, this is what we would deem a basic cell in that there is an automated conveyor bringing in a product, but the pallets are manually brought in and taken out of the cell via forklift, via pallet jack, by operators, and that's really governing the flow in and out. Takes out a lot of complexity compared to the cell we'll see next. Lower cost point, but again, improves on that safety aspect that we talked about, certainly improves on throughput, etc. So looking at a more fully automated system, and not uncommon that a customer would start with the previous system, a more basic system, and as they grow accustomed to that operation, felt the benefit, etc., kind of graduate to something like this. But this is a more, again, fully automated system, and I'll walk through the basic steps here. The blue machine in the upper left, excuse me, is a pallet destacker. So a stack of 10 or 15 pallets is placed in that unit by a forklift, and that dispenser will then kick out a pallet on demand when there's availability on the conveyor system. 2 product in-feed conveyors to the northeast in that image will be bringing product into a centrally located robot. And then the pallet conveyor will convey the empty pallets into one of 2 load zones, and they are to the right and to the left of the robot itself. So that robot, based on what it's picking up and based on what's available, will make decisions. Am I palletizing right? Am I palletizing left? That can be the same product. It can be 2 different products. But in essence, it is always moving. It is taking advantage of every moment to perform work. Once the pallet, a pallet or both pallets are complete, the robot is signaled back that stacking is complete for that pallet, and the pallet will automatically convey out of the cell. Again, each of the openings shown here protected via light curtains and other safety means, and the system's actually programmed such that it knows when a pallet is approaching a light curtain, so it can mute the light curtain, allow the pallet out, and then reestablish that safety barrier that is in place. So a few notes in closing concerning the robot's capabilities. As mentioned earlier, the robot can handle a variety of product shapes and sizes. We just took a look at a few different robot cells and what those might look like. Taking a look at the images on the screen, the leftmost image is, again, a clamp-style end effector that can handle boxes and other like-sized items. But on the inset picture, there's a small vacuum-style end effector. Handling the same box, performs the same function, but it also allows some other capabilities that might be beneficial to the cell. And if you move your attention to the rightmost image, that's actually showing another style of vacuum end effector. That one, as shown in the image, picking up an entire pallet. So not uncommon to have a vacuum style end effector employed where you're palletizing boxes, because you can pick a pallet off a stack, place it in the proper location, pick boxes to it, pick a slip sheet with the same end effector, place it on top of the finished pallet of boxes, and then convey it out. And you're saving on conveyance and other technology needed to be brought into the cell, saving on cost, simply by employing what we'll say is a little more versatile end effector. But then at times you need an end effector that's very, we'll say, specialized to what you're picking up. For example, if it's bottles or bags or other things that require perhaps a little bit different type of grip. And then finally, I want to introduce in the center image something that looks a little odd, but it's a robot wearing a jacket. In addition to the circumstances where, in general, manual palletizing is labor intensive and physically demanding and costly, etc. Well, there's also the application where the operation needs to occur in either a dirty environment, dusty, dirty, whatever it is, whether, you know, bags of cement, bags of kitty litter, whatever it is, where it just might have a powder in the air or dirt in general, or there's an environment where it might be in a cooler and the temperatures are such that it's not ideal for operators to spend long periods of time in there. So there are jackets and other accessories that can be added to the robot to make them, or to protect them in these types of environment and make them just as effective in there as they would be in a standard, let's say, clean warehouse environment. The point being that the robots are flexible, versatile, and can be outfitted per most applications. It's simply a matter of defining what the application requires alongside a partner, and then defining, again, specifying the proper equipment and ensuring that it meets the ultimate goal. So at this time, I know we went through a lot of material and pretty quickly, but I believe Kimberly might help facilitate questions that may be out there.
Mike, yes, sorry about that. We got a few questions in, and the first question is, what type of measures are put in place to ensure operator safety? Yeah,
that is a pretty common question asked, and typically one of the earliest questions asked in an engagement. I had mentioned light curtains that are used around the cell. Obviously, so safety fencing, a standard in the industry, meets all OSHA requirements, would be used for the basic barrier. Light curtains protect all of the openings from personnel, as well as monitor traffic flow of product in and out. And then there's a series of e-stops positioned in proper locations, etc. And all of this, as it relates to the cell, from a controls point, is tied into the surrounding conveyor equipment as well. So everything works seamlessly as an entire cell is tied together, that if there's an issue in one location, it prompts the other locations in the operation to stop as well and wait for operator engagement.
Great. Our next question is, how long does a changeover typically take?
So in many cases, the robots, and when we're talking about changeover, I'm assuming that we're talking about a product changeover. In many cases, the lines that are being serviced by these robots are running the same things for, we'll say, several hours a day, typically days at a time, the same product. Really, the changeover applies to removing an end effector and putting a different one on, which could take 20, 25 minutes. Or in more cases, you might have just product variation in sizes, so it might be an adjustment on a clamp so that it's a different range of clamping measurement, we'll say, in which that case, that's 5 minutes of changeover. So it really depends on the extent of the changeover required, and are you going from one product size to a slightly different product size, or totally changing the purpose of the cell at that moment. And then Kimberly, I thought you said there was a third. Yeah, I'm sorry, go ahead.
We have one final question, which is, how is service and support typically handled?
Yeah, so service and support, we always promote that the end user has on-site maintenance, or at least educated folks that know what signs to watch for in terms of proper operation of the machine. there is a preventative maintenance plan that's provided to the end user so that they can manage some of that routine week-to-week type of maintenance. However, for quarterly PM visits or emergency repair, usually that's run through PeakLogix when we put the cells in place. And we are supported then by Fuji Robotics, who headquartered in Japan, also has a U.S. headquarters and some technical offices around the country. But in many cases, PeakLogix would come in and perform, again, that quarterly maintenance, or if there's emergency repair or adjustment that would need to be made, we can perform that as well. Ultimately, again, the goal being that the robots are simple and they're performing repetitive acts, repetitive motions, repetitive functions. So the goal is that if there's anything that's out of sorts, it's very clear to the end user, and that can be addressed pretty quickly.
Great, and with that, I think we have wrapped up our third webinar. Mike, I want to extend our thanks to you to spending some time walking through robotic palletizing, and hopefully the audience has gotten a pretty nice insight into whether it might be a viable option for implementation.